And now I would like to welcome Simin, Nadjm Tehrani. Nadjm Tehrani is professor at Linköping University and coordinator of the National RICS Research Center. And RICS stands for Resilient Information and Control Systems.
Thank you. Let me just bring my own slide. Here we are. They asked me to talk about this project. It's gone for 7 years in 10 minutes. I could talk hours about it, so thank you for coming. I hope I can give you something to take away from here. I have the privilege of leading this center in cybersecurity that MSB finances, and I have 2 talented younger professors, Magnus Almgren, who's not in the room, and from Chalmers, and Matthias Ekstedt from KTH, who's not here today, and parts of their groups collaborating. So what's RICS? It's originally a 5-year project by MSB, which finished in 2020. We got an extension of 3 years, but it's slowly picking up after the pandemic. Magnus hasn't yet recruited a new PhD. And if I have to say something for the academics in the room, maybe we should say that over 95%, I think over 95 publications, 100 publications, 3 universities, 2 PhDs graduated, 2 associate professors, docent. One of them is Magnus, who's here, and another one, Mikael Asplund, you might have heard this morning. And we've had a lot of international collaborations, 3 conferences on security held in Sweden due to our engagement, and lots of master and bachelor students gone into industry. We hope they are contributing already to the work you do. We've had a lot of international collaborations. It doesn't fit in more than, you can't get more than this into one slide. So that was the sort of academic presentation. I'm going to now say something for the others who are not academics. The 3 research pillars, what we call in this project, have been first, we called it data emulation layer, because at the time we thought that we need to understand control systems, information systems that are in the OT environments, SCADA systems. And to do that, we need data, which is not available. So either we have to somehow get hold of such data, or we have to do synthetic data that looks like real data. We ended up with a testbed. I will show you one slide on that. The second pillar is to have methods to prevent attacks. In there, you have things like attack modeling, and you have risk analysis tools. We've worked on various topics in that, and I show you maybe one slide on that. And then there is detection and reaction to attacks. We've had both work at Chalmers and Linköping on that topic. Scientific achievements, if I have to say a few words about each of those pillars. The first one is this testbed that we set up at FOI, and is still being maintained by them. So basically, all of you must probably have heard of Crate, but Crate was an IT environment at the time. When this project started, we built an OT environment on top of Crate. So we have a testbed as an electricity distribution company, if you like. And in that, we can have things like an OT agent who can create scenarios, OT-like, and attack agents, and so on. As it comes to the third one, sorry, I start from the third pillar, which was detection. Anomaly detection, we've had work in 2 universities. At Chalmers, we've had 1 PhD student who finished and worked with some kind of spectrum analysis in order to get process variable data and react if something is wrong. And this is model-free, no specifications or rules about attacks, just detecting anomalies. And in Linköping, I had 1 PhD student who worked on network traffic data, TCP dumps, but with protocol specific for SCADA. And actually there, we are looking at both statistical methods and machine learning methods, and looking only at timing. If you have only timing data and not the packet payload data, can you do any anomaly detection? So at the time, it was kind of new, and of course, she graduated last December, and we've got papers, both Magnus doctorand and my PhD student, we have published in top conferences. In KTH, there was some specific work. This is, again, a selection. They've had specific work on attack modeling, which is building meta-languages for representing SCADA-like systems attacks. And from their finding for a given system description, what are the attack paths and what are the time to compromise to various nodes in this system. Now I'm going to switch to the things which is maybe more interesting for the non-academic stakeholders. We've had a large group of stakeholders. Of course, this virtual RICS AL, what we call it, the virtual network, the testbed, it's been used in Locked Shield. It's been used in many training sessions and environments for what FUI uses it for awareness exercises in the rest of country. This part, if you like, this doesn't show that. No, of course, I'm used to teaching environments. So the left part is basically the crate stuff, and the right part is the SCADA part. The SCADA part is a real network management from ABB, sitting there with the backend with 3 substations, RTU emulations, and WAN networks. And as you see, I'm so used to showing things not by hand. So the OT bot, the attack bot, and the scenario bot, which will create new scenarios. And we generate data, so we can use the data for testing anomaly detection systems. And of course, it can be available for external researchers, other places to use it. This is basically the a screenshot from this. So it looks like a real environment for a real operator in an OT environment. And 12 attack scenarios have been demonstrated and documented, and yeah, we've got data on it. The Chalmers startup, after the PhD student graduated, he started a startup, OT, Omen Technologies, looking like OT. And it was actually 2021 bought by Clavister, who's present here. And the LIU work was tested in some sense on real utility data, which we collected with you know how it is to get data out of utilities is impossible. So what you do is that you gave them a piece of code. You say, look at this piece of code if you're prepared to use it in your systems, and give us the timestamps of your packets for 1 month, which is basically what we got. And then we could actually start using this normality data to learn normal models. And then we did the anomaly detection based on that. There is a popular science version of our work on the MSB webpage. If you just Google on MSB or MSB 1701, you get this report. Basically, what you see is that we've had 3 approaches to risk assessment tested in the project. My previous student worked with asset-based risk analysis. Matthias' work was about attacks as a main driver of risk analysis. And recently, the past 2 or 3 years, I worked with University of Cardiff and Airbus Group on another approach to risk analysis, which is service-based. Basically, if you want your service to be delivered, what are all the things the service is dependent on, and how do you build this dependency model so that you can assess what will increase my probability of my service being delivered and what will not do it. And of course, when you want to put your money on where in my network and what do I spend my money on. This is important to know which things will improve your security at the top-level service layer and which ones don't. So you will find something about that in this report, a basic description of it. Matthias' work ended up, a lot of it, in a tool called SecurityCAD, which is in a company for City, recently bought by a major IT company. I'm not sure if I want to inform you on that, because if Matthias here, you would have called you. You could have talked to him, and he would have told you. But anyway, this is one of the 2 companies that have been actually resulting from this. Here is a top-level description of the work I did with the University of Cardiff and Airbus. Again, it's an open report on the bottom of the slides. Basically, what we did, we had 36 experts who are from various levels of experience, from 1 year to 40 years in SCADA systems, and from managerial, what you call it, operation levels, and all the way from managerial to operation and strategic levels. And we got them to tell us what do they think SCADA systems services are dependent on. We got tons of, through this capturing method which we had, tons of primitives, something over 600 primitives in their systems, and we reduced all the duplications and so on. We ended up with a model, if you like, a blueprint, a giant model of 450 such dependencies that could exist in a SCADA model. And then this particular thing, this huge model, is available in a tool, open source, and it can be used for a company who says, okay, I take not all the 451, but I want this subset, a bigger one, a smaller one, whatever, well, not bigger one, I doubt if it's possible, but a smaller one. If I want to build my own model, how do I use this as a starting point in some sense? And we ended up seeing that you have in SCADA systems things which you're dependent on your system architecture, of course, your management, your data, your system lifecycle, your employees, and external dependencies, of course, all these supply chain and third-party things. You've heard lots about them, and we saw them here as well. And these leaves, if you like, are somewhere here, many, many layers, you know, the tree growing in various directions. So that's basically my last slide. And if you want to know who were involved in the work, this is some logos for you. Thank you very much.
Thank you. Thank you very much, Simin. Thanks.